Hello, geometry students. Today we are going to look at section 9.5, which is going to continue to use trigonometry functions, but this time they're going to be all in application problems that involve angles of elevation or angles of depression. So right in front of you, you've got the beginning of the notes. The top of the page shows a diagram right here that basically gives us what it means to be an angle of depression versus an angle of elevation. An angle of depression would be, you see the blue line would be like, let's say this is a building, okay, and a person is standing at the top of the building and they're looking straight out. That would be like their line of sight. Now, if they were to look down at this point over here, the angle formed between the horizontal and this diagonal line, where now their line of sight is facing, would be called an angle of depression. It's called depression because it's going downward from a given reference point, okay? Whereas an angle of elevation would be an angle that goes upward from a given reference point. So let's say you had a person standing here at the bottom of a cliff, okay, looking upward. The angle that their line of sight to the top of the cliff forms with the horizontal ground, the green line, would be called an angle of elevation. Now, in both of these scenarios, whether you're describing an angle of elevation or an angle of depression, you're making an acute angle with a horizontal line. And you could always connect the other end of that horizontal line. You could drop it straight down or make a line straight up, and you end up with a right triangle. So these angle of elevation and depression problems always end up being right triangle trigonometry problems. So let's look at this first example. It says a diagonal of a rectangle measures 5 centimeters. I drew a little rectangle. I made the diagonal 5 centimeters. That diagonal makes an angle of 71 degrees with a side of the rectangle. I chose, just because of the way that I drew this, to focus on this angle. It looked like it could be about a 71-degree angle to me. So I labeled that one 71 degrees. Find the dimensions of the rectangle to the nearest tenth of a centimeter. All right, so I noticed that the diagonal splits a rectangle into 2 right triangles. Now I know this acute angle is 71 degrees, and I know the hypotenuse is 5 because the hypotenuse is across from the right angle. So I labeled my length and width, and now if I would like to find one of these measures, I think I started over here trying to find the length. And I said, okay, in relationship to the acute angle that I know, 71 degrees, I happen to know the hypotenuse, and I'm looking for the adjacent side. So what trigonometry function brings together hypotenuse and adjacent? Adjacent and hypotenuse. That would be cosine, C-A-H. So I decided to set up an equation, cosine of 71, it's always cosine of an angle, is equal to adjacent over hypotenuse. In this case, the adjacent is the length and the hypotenuse is the 5. So in order to solve for length, I notice L is being divided by 5, and I want to get rid of that. So I'm going to multiply both sides by 5, which means that L ends up by itself equal to 5 times the cosine of 71. And that's just a calculator problem. Plug in 5 times cosine of 71, you get 1.6. All right, that's the length. Now, I could use Pythagorean theorem from this point to figure out W. That's one option. But actually, I decided to just get more practice with trigonometry, and I changed my perspective about what I'm looking for. Now that I know the length, I'm looking for the width. And so this angle 71 is across from the width. So this is now the opposite, and that's still the hypotenuse. So what trigonometry function can help me if I'm talking about the opposite and the hypotenuse together? That would be sine. Sine equals opposite over hypotenuse. That's the trig ratio. So, the SOH part of SOHCAHTOA. So sine equals opposite over hypotenuse. Here's that set up as an equation with the stuff plugged in. Sine of the angle, 71, is equal to opposite W over hypotenuse, 5. Then I multiply both sides by 5 to get W isolated by itself, and I end up with W equals 5 times the sine of 71, which, plug it in your calculator, equals 4.7. So there's our length and width, the dimensions of the rectangle, to the nearest tenth of a centimeter. Okay, moving on to example 2. It says, when the angle of elevation of the sun measures 72 degrees, there's that word, angle of elevation, measures 72 degrees. A tower casts a 26-meter shadow. How tall is the tower? So here's my sun. Its rays are shining on this tower, and the tower is casting a shadow. The shadow is here along the ground, you know? Shadows are on the ground. So the tower forms a 90-degree angle with the ground, and the sun rays are forming that shadow by just, basically we're tracing out a sun ray here with the hypotenuse. So the question is, can we use this information to tell how tall the tower is? And the answer is yes, because we have a right triangle. We know one of the acute angles because they tell us the angle of elevation is 42 degrees. Okay, so 42 degrees is the measure of this ray with the ground. We know the adjacent side because that's the length of the shadow, and we care about the opposite side. That's the hypotenuse. So I'm going to use tangent because TOA. So TOA, TOA. Tangent is opposite over adjacent. So tangent of the angle equals opposite over adjacent. Tan of 42 equals h over 26 in this case. Now to solve for h, I got to isolate it. I got to undo whatever's around it. Right now it's being divided by 26, so I multiply by 26 on both sides of the equation. Got to always do the same thing to both sides, keep the balance. And that cancels out the 26 over here, leaving us with h. Therefore, we have 26 times the tan of 42, and the answer is 23.4 meters tall is the tower. Okay, I'm going to move to the next example 3. There's not a lot of space on the page here, but example 3 says, from a treehouse, the angle of depression, should really say to the base of a house, measures 53 degrees. The tree is 12 meters from the base of the house. How far is the tree house from the base of the house? So this might sound like repetitive and like they're asking the same question as what they told you, but it's not. The tree house is up in the tree. The angle of depression, if you were to look straight out versus looking down to the base of the house, the angle of depression going down here is 53 degrees. So the straight out horizontal is the distance from the tree to the house. But they're asking us how far is the tree house from the base of the house. So what they're really looking for is the hypotenuse here of this right triangle. We know the angle of depression is 53. We know the distance from tree to house is 12. That 12 happens to be not the hypotenuse of the triangle. It happens to be adjacent to the angle that we know. So we've got adjacent and we've got hypotenuse. Identifying the parts that you have and that you're looking for, that is the key to using trig functions. If you can identify them, whether they are hypotenuse, adjacent, or opposite, then the combination of what you have and what you're looking for can always tell you which trig function to use. So A and H, that's cosine. Cosine is adjacent over hypotenuse, CAH. So here I write the cosine ratio function equation. Cosine of the angle equals adjacent over hypotenuse. Plug in the angle, plug in the adjacent, plug in the unknown for hypotenuse. Then, in this case, since the x is in the bottom of the fraction, I'm basically going to cross multiply and then divide to get x by itself. So x times the cosine of 53 is equal to 12 times 1, which is the bottom of this fraction over here, if you think of it that way. Then to get x by itself, you would divide by the cosine of 53. There's a little shortcut. When the x is in the bottom of the fraction, you can literally just swap the bottom of the fraction here with everything over here, just because of the way ratios and proportions work. You can switch the cross products and it does not make a difference. So we can go from this equation to this equation, and that's totally fine. That's an algebraic equivalent. So 12 divided by the cosine of 53 is the answer for x. And all we have to do is plug that whole thing into the calculator. And you should definitely be plugging these things into your own calculator so that you know how to do it. If you never try it yourself and you just trust me that the answer is 19.9, then when it comes time for you to do your own problems and you plug it into a calculator for the first time, you may not realize that you have questions about how it should be done or how it should come out. So that's my little pep talk. You should try these things yourself, plug them in, verify that it's working. Okay. Example 4, the angle of elevation from a ship to the top of a 35-meter lighthouse on the coast measures 26 degrees. How far from the coast is the ship? So assuming that the lighthouse is right on the edge of the coast, it's 35 meters tall. The ship angle of elevation from there to the top of the lighthouse is 36 degrees. We can figure out the distance from the ship to the shoreline, the coast. So let's identify the parts. Here's the acute angle we know. The side we care about, the one that we are looking for that is unknown, is right next to, it's attached to that acute angle. It's the adjacent side. And the hypotenuse is here. We actually don't care about that. We know about the opposite side, and we care about the adjacent side. So what trig ratio brings together opposite and adjacent? That would be tangent. TOA. Tangent equals opposite over adjacent. Tan of 26 equals 35 over x. Tan 26 equals 35 over x. All right, this is another one of those situations where the x is in the bottom of the fraction. And like I said up here, there's a shortcut you can take. This x here can be swapped completely with tan of 26. It's just like you are switching the cross products of, you're thinking of this as like a fraction over 1, and then you're just switching the cross products and they're totally equal either way you write them. So x can be isolated by just swapping it with what's over here. X equals 35 over tan of 26. If you don't believe me, go ahead and make this into a fraction, put a 1 underneath, cross multiply, and solve for x. You will get 35 over tan of 26, which in the calculator comes out 71.8 meters. All right, on this next one, I'm going to try to draw on the screen because I did not have the answer written up already, and I'm going to do this one on the fly. So you'll be drawing along with me. We have a kite. I'm going to draw a kite. It is flying at the end of a 150-meter string. Whoa, that is not a very straight string. Okay, I think that's a little better. I'm going to try drawing this way. The string makes an angle of 75 degrees with the ground. So let's draw the ground, and the angle it makes is 75 degrees. How high above the ground is the kite? Basically, this is the question. What's the height of the kite above the ground? Here's the right angle down here. This is the right angle. So this is the hypotenuse here. We actually don't care about that. Oh, wait a minute. Yes, we do. The hypotenuse is the string, which is 150 meters. So let's put that on there, 150. And now we need to consider, what do we know and what are we looking to find in terms of opposite adjacent hypotenuse? Compared to this angle, the x is opposite and the string is hypotenuse. So which trig function puts together opposite and hypotenuse? That would be sine. Sine equals opposite over hypotenuse, because so, ka, toa is our go-to phrase for all trigonometry. So we're going to use sine equals opposite over hypotenuse. Sine of the angle, I'm just going to write the angle right in there right away, equals opposite. Opposite is what we're looking for. That's our x. Hypotenuse is 150. So there's our equation. Solve this simply by multiplying both sides by 150 to get x by itself. That cancels out over on that side, leaves x equals 150 times the sine of 75. And I don't know if you'll be able to hear me typing it into my calculator. 150 times the sine of 75. Whoops, I pressed tan. Better keep an eye on that screen while you're typing. Make sure you don't make any typos like I just did. The answer is 144.89, or approximately 144.9 meters. Okay, let's move on to example 6. A ramp is 60 meters long. It rises a vertical distance of 8 meters. Find the measure of the angle of elevation. Okay, so the ramp is probably going, up from the ground, forming a straight. You could kind of drop down from the top of the ramp straight down to the ground and form a right angle. The ramp is 60 meters long. That would be the distance a person would travel along the ramp. So that is the hypotenuse of the right triangle. The vertical rise over here is 8 meters. That's okay. And the question is, what's the angle of elevation here? So we're going to put A for angle. We don't know the angle, but the two parts we do know are opposite and hypotenuse. Opposite and hypotenuse. Which trig function puts together opposite and hypotenuse? By now you're going to get sick of this, but I'm going to just write it out again. So, ka, toa. And I hope that you will write it out as much as you can to memorize it as well. So, ka, toa. OH, opposite hypotenuse. That's sine. So I'm going to use sine of the angle equals opposite over hypotenuse. So it's sine of A equals 8 over 60. This is one of those questions where the angle is what we're trying to find. It's the unknown. It is trapped inside the sine function. We've got to somehow unwrap it from being in the sine function. So what we need to do is the opposite of sine to get rid of the sine from around A. What's the opposite of sine? It's actually something called inverse sine, or sine to the -1. That's called arc sine. So we're going to basically do inverse sine to both sides of the equation. Sine to the -1 on the left and sine to the -1 on the right. Over on the left, these two things cancel each other out, leaving us with A. On the right-hand side, we get the expression we're going to type in the calculator is sine to the -1 of 8 over 60. And that's just a calculator problem. But remember, you have to press the second button and then the sine button to get the little -1 function, the arc sine function. And when I put that in, you should try it yourself. But I'm getting an answer of 7.66, and the answer would be in meters. So, oh, no, I'm sorry, it's not meters, it's degrees. This is an angle we're talking about. 7.66 degrees. Okay, I know you may have 2 more examples on your page, but in the interest of time, I'm going to say I'm not going to show those in this video. You could try them yourself as more examples, but you're also going to try some problems. So those problems are attached to this classroom post, and I hope that this has been helpful to show you some more examples of trigonometry, as well as illustrate what does it mean by angle of elevation and angle of depression. All right, take care and do your best, and we are getting close to the end of this chapter, when we will actually assess your knowledge of right triangles and trigonometry. Have a great day.